This is the pre-exposure video for the substitution rule. It has its roots in the chain rule. So if you want to think of the chain rule in reverse, that would be a good description of the substitution rule. You want to use substitution whenever you see, well, you want to try substitution, I should say, whenever you see that you have a composite function in the integram. This is sometimes called the change of variables method. And I know when I first learned this technique that was what I had been told it was called. So if you hear that verbiage, it's the same thing. I want to present the formal theorem for you and then try and explain what it is that they're telling us here. So we're going to let u equal the function g of x in this integram, and g prime needs to be continuous on an interval, and then the corresponding function f that you're putting g prime into needs to be continuous on the corresponding range of g. And all that really is saying is, and if you think back to your first experience with the composition operator, if you put x into f, you get the result of f of x, right? And then that range of f of x needs to be able to satisfy the domain of the next function that you're going to put it into. So it's sort of that concept, if you will. But what does this formula tell us? And how do we use it? So if you look at the expression on the left-hand side of the equal sign, g of x is going to be u. And then if I differentiate u with respect to x, I'm going to get the other piece of this. And you need the dx. Don't forget the dx because you're integrating with respect to x. And if you look at the expression, well, that's simply du. And now you can make the substitutions and you get the right-hand side of this equation, which is f of u and then du. So how does that equate to an example? And you'll see it in a moment when I send the other video off. But for now, I just want to go through a step-by-step procedure to help you get through the substitution rule the first time you see it. And then when you get comfortable with it, you will by sure abandon some of these things that I'm going to tell you. But for now, let's go through the procedure. Let me pick another color here. All right. So the procedure for substitution, the first step, we're going to have to choose u. So we're going to let u equal the inner function. And by far, this is the hardest part of the substitution rule, choosing u. What do you let u be? And some hints might be if you let, if you see powers, so if you have x to the n multiplied by x to the n minus 1, you're going to let u equal x to the n, because when you take the derivative, you're going to get a power of 1 degree less. So that's one tip. You also need to look at trig functions, you know, in the derivatives and integrals of those trig functions to help you. But again, as you get further and further along with this procedure, you will get a feel for what to let u equal. But like anything in mathematics, if you fail the first time, you try again. Okay, you try something. You let u equal something, and then try the procedure. If it doesn't work and doesn't get you a simpler integram, the goal here is to get a simpler integram. Let me write that goal down for you. So the goal of substitution is to get a simpler integram from a more complicated one. All right, so that first big step is choosing u. The second step is just taking the derivative of u with respect to x. All right, so find du. And don't forget that dx, right? So you're finding du. Find du. Your third step in the procedure is going to be algebraically to solve for du. Solve for dx. so that we can make the substitution. And your fourth step is to make the substitution for u and dx, and then perform any algebra that you need. So perform or make the substitution for u and dx, and use your algebra. Algebra is your friend in calculus. Right? They dance together. So you want to make those substitutions and clean it up. Then solve the integral. Take the antiderivative, in other words. So solve the integral. And then lastly, you want to substitute back. So you want to substitute g of x back in for u. And this will become clearer as we look at an example. A couple things to remember with this procedure. Right? You're making substitutions, and substitution is a very powerful mathematical technique. Right? You're going from x's to u's and then back to x's. Right? The problem originally started with x, and we're making a u substitution in hopes that it's going to simplify the problem. But you can't leave it in terms of u. You've got to get back to x, because the original problem was in terms of x. So your answer needs to be in terms of x. All right, so that's the first conceptual thing that you need to understand. And the other point I'd like to make at this juncture is that not all functions have antiderivatives. So this doesn't always work, right? And you'll learn techniques to handle this situation, but not all functions have antiderivatives, and that's okay. We'll learn some other fancy things to do when we back ourselves into a corner, which, if you're like me, happens frequently with this. Okay? So that's the overarching message here. You're going from x to u, back to x, and the problem that you get in terms of u is supposed to be a tad simpler, you hope, right, than the original problem in terms of x.